Sarah, got do the work.
I don't know how to question 11, but 4 is done.
Sorry, what you say?
I don't know how to question 11.
The swimming pool one.
Yeah.
Okay, Phoebe?
Same. I don't know how to do.
Huh? This one.
Yeah.
Sarah, later, Sarah, you got the phone or not? No, huh?
I have.
You have the phone already, huh? Then can use the phone. Yeah, so
Yeah, I got the PDF.
because I just sent you all the soft copy part. Yeah. You can actually put in your PDF file into a computer. So if let's say phone is not convenient or what, then put it into computer, then you can also access from there. No need to always use the phone. Okay? Yeah. Hello, engineer. Yeah. Okay. Did you do the question? Can do?
I sent you my working already, then you marked it already.
This question, man?
Yeah, this question.
Are you sure? I got dementia.
Yeah, I'm sure.
Huh?
I'm sure I sent you. You marked already.
Someone mark for me on my behalf.
Okay.
Wait, Who's that? Oh, okay. I'm going to do something. Not this one, engineer. That one. This one is an older one. It's the older one.
No, I sent you everything. I
Everything.
did it on the day itself. Yeah.
Oh, did I mark?
Yeah, you
Oh
did.
yeah, I did. Okay. Someone mark for me. So thankful. Okay. Okay. Because I've been marking other people's work. Then I forgot who. Yeah. Okay. I'm going to this question. Yeah. To do this question, okay, you need to first get the chain rule because this is your rate of change problem. Okay, I'm going to do something to Samantha's mic. Yeah. Okay. Rate of change, we will do the this chain rule. The question was asking to find DHDT. So you have to look at DHDT and this given to you the DVDT. Then you form a chain rule with these two quantities. So the chain rule to form will be just dVdh times dHdt equal to dVdt. So this is your basic chain rule starting equation. Yeah. Then after that, you already know that this quantity is 5 meter cube per minute. Yeah. Then what you need to do is to get this guy. Okay. So we are going to get this fella dv over dh. So to get the dvdh, then you need to know the volume. Okay. And this volume can be found with the basic formula for volume of a prism. Yeah, so it's just base area times the width. Okay, it's a prism. Prism is any shape that is with the same constant section area. Okay, like this section area. Then times the width. Get me something like that. So the width is 10. So that's your swimming pool part. Okay. So this base area is given by half times base times height times 10. Okay, so where h is depth of water then B is the so-called the length. Yeah, something like that, the length here. Not a very good description, but that will do. Okay, people understand what you're trying to get in. Yeah, then after that, we talked about it before. When you're going to find dVdh, to find dVdh, I cannot allow myself to have another variable. This is the variable because when your depth of water increases, then your B will be different. It will be longer or shorter. Okay, so your B becomes a variable, which we will try to kick it out. Okay, so you need another information to re-express your B away. Okay, so to get the B away, we look at this guy. Okay, what is this guy? This guy is your similar triangle. Okay, there'll be a blue triangle versus the orange one. Okay, so there are two of them here. One is this, the other one is the bigger one, the blue one. Yeah, get it? So the bigger one will have 50 and 3. Okay, well, you also, right? Okay, so Phoebe's one also muted, very noisy. Okay, so you have 50 and 3 because here is 3. Yeah, 4 is the whole thing. So 4 minus 1 is 3. Okay, and this part is H and B. Then we do a similar triangle. By a similar triangle, this is your B over H equal to 50 over 3. Whenever you see all this triangle problem, you will have to prepare for a similar triangle. Okay, so after that, you try to make your B the subject so that you can substitute out. So this is your B formula. Then you're going to sub it into your volume formula to take away the B. So we have the E to B or the V to B half times base times the height 10 times the 10. So all in all, this gives you 250 over 3 h squared. Yeah, so this is your volume expression. Then with the h being only one variable, we can differentiate safely. So differentiate, you get 500 over 3h. Yeah, once you get this quantity, this will be good. Then we can put it into your chain rule. Okay, so we are going to sub it into the chain rule. If you want to organize it, then it will be good to label equations. Okay, you'll find that when you do questions, solutions become longer and longer. So it's important to organize your solution, give names to equations whenever necessary, so that your teacher can see which part are you trying to work with to sub in into. Right, so sub into 1. Okay, so you have 500 over 3h times dh dt equal to dv dt, and then we sub in the numerical values. Five and h is 1, given the question when the tab is 1, I think. Yeah, is 1. So sub it in, then you find your dh dt. Then you find your dh dt. Yeah, then write the unit down. Okay, something like that. I feel this question is not really that difficult, not so like wow, very extremely difficult. Okay, the only difficult part maybe if you encounter problem is the similar triangle, the blue color part. Okay, so take note of the similar triangle. Whenever you see triangle, cone, some triangular surfaces and shape, think of similar triangle. Maybe it will be an approach. I don't know whether it will be used, but it will be worth to consider, okay, as an option when you solve problem. All right, so this will complete your part A. Then your part B, right? Part B, we will need this chain rule again. Okay, because part B is asking the same thing, except that they describe the tap of the water as the half full. Okay, so I'm going to erase certain thing. You all finished copying already? Probably I erase this part here. I think this part you all finished already. This part, it would be good if they have an eraser. I can't find eraser. Eraser would be good, can erase. Yeah, so I need this quantity. I need the V, dVdh, and the V. Yeah, so these are the quantities I need, okay, to do part B. So done. Can I continue with part B? Okay, for part B, it will be done this way. What is meant by half full? To be half full, you need to calculate the total volume of the pool. The total volume is the volume made by the top rectangular part plus the volume made by the bottom triangular part. Okay, so there are two volumes there. One is the top part. Top part is 1 times 50 times 10. See the shape, 1 times 50 times 10. So the top part is here. Who is making the noise? Okay. The second part is a triangular part, triangular face. So this one is your 3 is the depth times 50, the base 50 here. The depth is 3. Then times 10. Here by 2 here because it's half times base times height. Yeah, so you get this part is the 3 and 50. Okay, here is 1 and 50 times 10 because of the volume, the width is 10 meter. Yeah, not a very big 10 meter. Quite small, quite 50 meter is the standard length of the pool. The width is standard length of the width of a pool is 25 meter. Yeah, so this is a bit small, a bit tight. Yeah, so this one will give you 1250. If you're going to work out all these things, you'll get 1250. Yeah, then half volume means simply (625). Okay, 625. Why we do all these things? It's because the objective is to find the height, the depth of the water. Okay, the depth of the water. We don't know the depth of the water, so half full will be somewhere maybe here. Then what is the depth? Okay, so that's the main concern we are looking at. Because once you know the depth, then we can find the dH/dt using the chain rule because of our previous parts, all done. Yeah, so now we go back to the question. The volume is this one. We no need to recalculate again. we already calculated just now. Okay, so the volume is 250. So we let 250 over 3h squared equal to 625. Yeah, then we find the h. Then once you find the h, then that's it, finish already. Okay, once you find the h, yeah, then you try to find the h, it will be square root 15 over 2. You can take the number as square root first so that you keep the accuracy. Then after that, you use the chain rule. Then you have dvdh dvdh is here. Then the chain rule, 1 times h times dh dt equal to dv dt, which is 5. Then you get your dh dt. Clear about this? So the only guy is your h, is your new h. You just need to put in. The rest are the same. Can? Okay, okay. There are many other questions in the worksheet. Really, like you finish your online, some of you the school, one day lesson, not maybe not your school, I don't know. But I know some schools, they have home-based learning. Then the home-based learning, own time, own target one. That means the day you can just log in and finish your work, then that's it, finish for the day. So some can finish like in 3 hours, they finish the whole day's work. Then they just submit and nothing to do really, very boring, Yeah, they'll throw chair, throw something down onto the street. Yeah. Okay, done. Then I move on to the next worksheet. That is your what is that integration? Okay. One, go to the next one. Yeah, the integration. Question 4. Okay. Any question here? Samantha? Okay. Sarah, okay, finish? Can get 0.010.
Yeah.
Yeah, something like that. So let's move on to question, the other one. Yeah, integration done. Then we go to the 4071 question 4. Fine. Okay, this question 4071b. Yeah. So this question, how do we do what topic from and so on. So you can see that the curve for which dy dx is this has stationary points 1 0 and -1, -3 3, -3 32. Yeah. You'll find that if you want to find the equation of the curve, you have to definitely reverse the process. Have to reverse the differentiation process. So this gives us an idea, this must be an integration chapter. Okay, so integration is the reverse of the differentiation process. Okay, that's the main thing in this chapter. Okay, of course, integration got other usage. So you'll see 3 important usage in integration in your step 4. Okay, this is number 1. Yeah, then after that, after maybe next lesson, we'll do the second application of integration. Yeah, then after that, there'll be a third one. Then there are three main ones. Okay, here. We take advantage of stationary points first. Maybe it will be good. What do I mean? Okay, at stationary point, dy dx is 0. So this is a very important info that you know. So we sub in okay, we sub in these 2 points to take advantage of the differentiation, right? Property. So you sub in 1 and sub in -3. So you get 1 first, you get 3, 1 square plus a 1 plus b equal to 0 from here. Yeah, then here you simplify the equation a little bit, you get a plus b equal to -3. Then after that we'll do the sub in for the other point. So the other point will come in here. So you sub in, you get 3 -3 square plus a -3 plus b also equal to 0 because of stationary points. Okay, then here you simplify. So you get the second equation. So do your mathematics, all these things properly. Then because here you have we haven't done any integration, because as far as possible we'll try to solve the problem within our own self, right? Our ability. We contain the problem as much as possible, we solve them, then after that we continue if we need to. Yeah, so from 1 and 2 you can find a and b. Yeah, I think using whatever simultaneous equation method you have, then you okay, you try to solve maybe things like 1 minus 2 elimination method. Yeah, so you have 4a equal to 24. So a is 6. Then sub a equal to 6 into any maybe number 1 is nice, looks is easier, then your b will be -9. So you have found your a and b, then so your equation, your dy dx equation will become so you have this equation. Okay, once you have this equation, then your question is still asking you something. They ask you find the equation of the curve, right? So you have to find equation of the curve after you found a and b. Okay, so this part we will use integration, no choice, because we have to go unwrap back the dy dx. Okay, so in this case we integrate. Yeah, we do integration to reverse the process. You get y equal to integrate this further. Yeah, I write in blue. So integrate, you get 3x 2 plus 1 over 2 plus 1. The 3 will be like just leave it alone, then you just integrate the x. Then the 6 leave it alone, integrate the x power 1 plus 1, 1 plus 1. The 9 integrate is 9x. Constant always gives you the x. Then plus c, don't forget the c, arbitrary constant. Then simplify. You get this equation. Yeah, there's still a last thing to do is to find your c. But finding C is quite simple. Reason is because you can just use one of the points to find. Okay, for example, from here 1 0, I can see my C already immediately. So C is 0. Right? Once your C is 0, done already. Therefore, the equation has to be y equal to s cubed plus 3x squared minus 9x. Then no more C because the C becomes 0. Wait. The C cannot be 0. How come?
Mr. Rao,
Yes.
x is 1.
Oh yeah, x is 1, not 0. Okay, then that's solved. Okay, so you all can go and correct it, this part here. Okay. So you go and solve your value for C. So you get 5. Yeah. Okay, thanks. So this is your equation of the curve. Yeah. So you can see the use of integration. Integration is to reverse the differentiation process. Okay, and it can occur in this sort of question whereby you are given a gradient function, you have to find the equation. Okay, good. So where's my okay? So I will finish. I close this. Any question here? Yeah, let me check something. Yeah. I wonder what is engineer writing, because you have done this question already. Oh, you are doing your other work, huh?
No.
You are copying this one.
Yeah.
Oh, but you have finished already, right? You have done it. It's something similar. Yeah.
But didn't we all do it?
Have what? I saw it. I don't know. Okay.
No, I
Yeah.
thought everyone did it.
Mm.
Yeah.
Can? So okay, so I clear this part. Okay, next part going to do is part 2. This part 2, then got the part 4, part 3, then got part 4. Yeah, okay, so part 2. This is, we are building up our integration skill. Okay, so integration is not easy in general. So we are building up to this algebra. Okay, this sort of function. This function is a power with a linear function in the under the power. So I just write here. Yeah, so we are trying to know how to integrate such function, and this sort of function, they are quite common throughout. Okay, so it will be good that we know how to do it. So let's bring you through this part. I'm not going to follow this part a lot. Okay, I just trying to explain to you in this intuitive sense. For example, if I ask you to differentiate, what's the answer? Bibi, what's the answer?
Chain rule.
Yeah, what's the answer then? Good.
And
You say first.
okay. Wait, let me write it down.
Oh, must write down one. Okay.
Yeah. Is it an times ax plus b to the power of n minus 1?
Then times A, right?
Times a, yeah.
Can very good, well done. Okay, correct. Yeah. Can all of you can follow? Sorry, I writing a big huh? Okay, so I move a bit in. Yeah, so this is the integration differentiation process. Okay, with the A extra there. Yeah, I write it back a bit. Just allow me this time to write it back. Here, bring down the n. Then you minus 1, then you times A. Okay, for integration, right? I write here, then you see whether you can catch or not. For integration, everything will be reversed. Okay, will be reversed. How does that mean? That means I have as plus b. Instead of times n, I will have to divide. Okay, so if you look at this part, I will just do my normal integration. Okay, normal integration tells us if I have a power n, I will have n plus 1 over n plus 1, right? Correct, everyone? Yeah, now what happened to the a? For differentiation, the a is been put to the side like times a. But for integration is reverse. So you always carry your reverse mentality. Then you'll find that, oh, for integration will be over a. Okay, then of course you need a plus c for always a arbitrary constant. So far, can understand this? So you just do your normal integration with the power. Then you don't forget, you must remember to take care of the feather inside, which is like your chain rule. Except that instead of times a, your this little special chain rule is divided by a. Yeah. So if you understand this, then this is your theorem 1. Theorem 2. Yeah. So this is our very important result. What important results we have covered so far? These are the few. So far I just summarize here. So important results are these. Okay, I thought it's very important. Then the second important result is integrate a constant. Because constant, some people find constant very uneasy to handle, like very strange. So it's important to know whenever you see a constant, it's just k times x. So there are these 3 results I feel very important. You remember them? This result is actually the extension of the first one. Okay, it's the extension. That means it's built up. Yeah, so I style it this way. So they are related. Okay, they are like one. This is level 1. The 1 star is level 1. The 2 stars is a level 2 type of the result. Is that matter okay? Yeah. Okay. So let's look at some of these questions. Example 8. As usual, we are not doing very step-by-step thing. So not like your school, going to explore and so on. So we'll go straight to some of these questions. Okay, part A. And then when we do, right, I just want to emphasize on using our basic formula, okay, to handle the 2-star question or 2-star result. Okay, so this one. We do integration normally. Deal with the power. Okay, deal with the power just like before, just like in the 1-star problem, we just treat the power, handle it properly. Then the second step is look at the function inside. It's a linear function, must be linear. If it's not linear, then we cannot do. Yeah, very important. If it's linear, then we just differentiate the 3x plus 2, you get 3. You make it over 3. Then plus c. Then the answer is 115. 3x plus 2 power 5 plus c. Get the yellow part. Yellow part, huh? Yeah. It's just a reverse of differentiation. So you'll find that whatever you do in differentiation, integration will have that reverse element. So we'll go opposing. So instead of times, you get divide. Yeah, take note of that. There's no very deep understanding here, because if you want to go through the result to get the result right, then these are the steps you follow. But not much. I wouldn't find much enlightenment here. So if you want to use the formula, it's just remember this part. Yeah, that will do. Okay. Yeah, I call it the reverse integration. Reverse chain rule. I call it okay. Let me type this. Yeah. So it's just a reverse chain rule. Okay, let's look at B. B. 8 over 1 minus 2x cubed power. Yeah, so here, just like our normal integration, you need to bring the term out. You cannot integrate anything at the bottom directly, so you have to bring it out. So after that, we just ignore the 8, then we integrate the term, which is a linear term again. So we deal with the power first, then after that we deal with the reverse chain rule. So differentiate the inner part, we get -2, right? Okay, -2. So we just 1 over -2. So I'm trying to teach you to use the chain rule skill to do integration here. Yeah. You'll find, is it a shortcut or not? Actually, not a shortcut. We have been using this mentality through to university. When we do integration in university, we also do the same thing. We also have this, carry this mentality of reverse chain rule and do problem. Yeah, okay. So after that, you just simplify it. Then you have 2 over 1 minus 2x square plus c. Do your mathematics, 8 all these things. -2, -2, -4, 2. Yeah. Can let's move to part B. Okay, I erase the part A. Part B, part C. Again, there's a 5, it's a fifth root. Then power 7. After you finish integration, not many topics left already. I think maybe 1 or 2 at most. Finish already. Yeah. Okay, so not many. So integration is the last big topic you are facing. So no more. Okay, here we have to make it to the index form. So it's 7 over 5. Okay, don't forget about all this fifth root, all these things. It's 7 over 5. Okay, then after that it's be normal business. Deal with the power first. Add 1 to the power. Then divide by the new power. Then after that, always ask yourself to remind yourself this is a linear term. So you differentiate, you get half. 2, you get 2, right? So you 1 over 2 of it. Yeah, so you still have to do some differentiation to get that number. So you just reverse the number. Okay, then after that simplify the the stuff. This is 12, so it's 5 over 24. You can write your answer in text notation form. No problem one. Don't need to write in the cert way. Yeah. Get it? If you get it, then we move on. We'll move on and on and on. Okay. Next one is D. Okay, for D, you cannot say, oh, I'm going to differentiate, I'm going to integrate the power, so it's 2 plus 1 over 2 plus 1. You cannot do that. Why? Because the power 2, inside the power 2, the term is not linear. You know linear? Linear is only ms plus c. So it's not linear. Therefore, we cannot use theorem 2. Okay, I just make a remark here. Linear means power 1 only, strictly only ax plus b, that's it, no more. So it's not linear, so we cannot use our theorem. Okay, our theorem only for ax plus b inside the power. Yeah, you get it? It's a very strict rule. You cannot deviate, even a small little step also cannot deviate. Okay, so you must really follow the rule. Yeah, so in this case we cannot use the theorem 2. So what to do? What do we do? No choice, we do expansion. Okay, a square minus 2ab plus b square. Okay, you have to expand 1a square minus 2ab plus b square, then integration sign throughout. Let's simplify the terms before we perform integration together for each term. Okay, so it's 1 minus, then the second term is 10 over the 3x minus 4 power 2. Then the last one is a square of the term, so the top is 25, 5 square. Bottom 3x minus 4 power 4. So far get it? Can? Sarah, okay?
Yeah.
Then after that, we are going to make it to a in text form. Bring all the terms up with the negative power. Yeah, until this step, then you can do your integration. Then integrate 1 is x. Then the 10, leave it alone. Then integrate the linear power term. We focus on the power first. Okay, then after that, always remind yourself it's a linear power. So differentiate 3x minus 4 is 3. So you have 1 over 3. Then continue, plus 25, leave it alone. Then the 3x minus 4, focus on the power, plus 1 over negative 4 plus 1. Then your chain rule effect, differentiate 3x minus 4 again is 1, is 3, is 1 over 3. Then plus c. Yeah, then finally, just simplify stuff a bit. So this gives you plus 10 over 3, 3x minus 4 is negative power, bring it down. Then minus, plus or minus 25 over 9, 3x minus 4 power 3, then plus c. Okay, so be careful. Yeah, so there's a minus here, so there's a minus, and here is a minus, so here is a minus. Yeah, I mean, if you can't handle the mathematics, just do it a few more steps to make sure. Yeah, so don't rush it. Here I don't have a lot of space, so some of these steps I will just compress it a bit. Yeah, okay. So all in all will be this sort of problem. Yeah, we look at the next one. I scroll it down. Yeah, this one. E. Okay, so you look at E. Just finish off this question. Even though I think we know what to do already. So this is E. So integrate. Yeah, similar to just now that question. Here is not a linear term, so you cannot just use the formula to do it. The formula is this one. You cannot use the formula, so we have to no choice expand. Then expand is a squared minus 2ab plus b squared. So we have this one. I do it a bit quicker. So it's a squared, so it's 6 minus 2ab plus b squared. 9. Yeah. Okay. Then after that, every term ready, we can integrate. So we integrate the power 6 plus 1 over 6 plus 1. Then chain rule is half, is 2, reverse it. Then for the second term, the 6 leave it alone. Then the power 3 plus 1 over 3 plus 1. Then again the same chain rule effect, reverse. Then plus 9x. Then plus c. Yeah. After that, just simplify. 7 times 2. Then 6 divided by 2, 3 divided by 4, so 3/4 plus 9x plus c. Yeah, so this will be our 8E. Make sure you know how to do these sort of questions, because the harder integration problems do not come from algebra. They come from trigo. We are going to learn trigo integration. So everything you learn in your differentiation involving trigo, you also learn here. So everything will be like have to go through one cycle again. Okay, so this is your example 8. Okay, if you are ready, let's look at example 9. Read the question. Yeah, example 9, very big. Okay. The gradient of a curve is this, and the curve passes through the point. Determine the equation. So again, it's not because of this topic that we do integration. It's more because we identify the question that they ask. So they want to find the equation. So it is from gradient to the equation. Therefore, it's integration. Okay, so we are sort of like reason out like that, so that you go exam, you are more prepared. Oh, this question is this topic. that question is another topic. Yeah. Okay, so here we start. We say let dy dx is the gradient be this term. Yeah, and then if you take a look, right, you find that 63 and 18, they have common factor 9. So it will be good habit to simplify it a bit. It's always no harm to take out common factor. It's actually a good habit so that you reduce the numbers, make it more manageable. So our simplified dy dx expression is this. And after that, to get the equation of the curve, we need to find y equal to something, right? Y equal to something. So we are going to do integration now. Yeah, so we integrate. Then we get y equal to 3. Then at the same time, let's cut down some steps. We write the square root as power half. So we can cut down a step. Don't need to write so many things. Then equal to the 3, leave it. Then 7 minus 2x. Focus on the power first. Then chain rule. Differentiate 7 minus 2x is negative 2. So we put a 1 over negative 2. Then plus c. Can follow? Okay. Yeah, so after that, you just do your mathematical sum simplification here. 3 over 2, 2 over 3, so it's negative. Yeah, so your y will be this expression with the c. Then we are going to find c. Yeah, to find c, we use the information. Let's make this smaller a bit. The curve passes through the point 1.52. So we just sub in. So we sub in 1.52. Then you have 2 equal to negative 7 minus 2 times 1.5 power 3 over 2 plus c. This one is just 4 to the power 3 over 2 plus c. So you can find c. Then okay, so you find your c to be 10. Therefore, finally, the equation of the curve will be with the c replaced to be 10. Yeah, so this will be your example 9. Yeah, then after that, we do integration of Trig. Okay. Yeah, recall differentiation. Differentiate sine is cosine. Differentiate cosine is negative sine. Differentiate tangent is secant square. Then if you are above average, you should also remember differentiate secant is secant tangent. Differentiate cosecant is negative cosecant cotangent. People find a way to remember the that thing. Then finally, cotangent differentiate is negative cosecant square, and people find a way to remember these two because they are co again. Yeah. Okay. Think of chocolate cocoa, then you'll see all these cocoa coming in. Yeah, the cocoa plant. Okay. Can I clear the board away? Okay. Why I ask you to remember? Because to your big advantage. If you remember, right, then we are going to do reverse of the differentiation. So you see, I just highlight this to you, this part. Okay, this part is differentiate sign is cosine. So when I reverse the process, I write here. Then if I reverse the process means I'm going to integrate both sides. Like that. Integrate both sides. I use the notation in this way, integrate both sides. So when you integrate, you'll get sine. Because you are unwrapping you are reversing the differentiation. Then here it will become this thing. And of course plus C lah. Okay, whatever you have, there will be a plus C. So I get this first formula. Yeah. Okay, it's like not so surprising lah, right? Just reverse. Okay, then I show you the second one, how to do it. Yeah, second one is this. I just copy down the result. Then again, I'm going to integrate both sides because I'm trying to reverse the process. Okay, all these things are like this. For example, you have a square root number, I square it, then you x, that type of thing. So square root and square, they form a pair of killing off each other, that type of thing. Okay, function like this in mathematics, they always come in pair. Like if you learn science, right, you learn matter, then after some time you learn antimatter. Very expensive, huh? If you get 1 gram of antimatter somehow, right, you get 1 gram. People will pay you trillions of dollars for that 1 gram of antimatter. Yeah, you go and Google what is the most expensive material in the world. Yeah, so you'll see antimatter comes number one. It's very, very expensive. My kid told me one, I don't know. Yeah, then he showed me, oh yeah, antimatter. Go and get some antimatter. We'll be rich, whatever. Yeah, okay. Go and Google. You'll find, wow, amazing. It's not 1 gram. It's just one liter nanogram or what only. Yeah, if you can get it, then you're rich. Yeah, so here, unwrap it, you'll get cosine. Then here is your negative sign. Right, no change. And of course, plus C lah. Okay, I reserve the plus C a bit later. Maybe I write first. Then you see, I bring the negative over. I can take number out of the integral. Number okay, but not the x itself. So when I take it over, then I get negative cosine x negative c. But this is just a constant, so I write it as c again. It's just an arbitrary constant. Nobody will know this constant, so I just write it back as that. So I write it in the reverse way. I write the cosine first. Then equal to sine. So I get the second one here. You see, that's something that people will start to get confused. So I hope you are not going to get confused. When you differentiate sine, you get cosine. Differentiate cosine, you get negative sine. But when you do integration, integrate cosine is sine. But integrate sine is negative cosine. So a bit, I don't know, do you feel that type of feeling? It's a bit anti, no? Yeah. So we have been always dealing with cosine, differentiate is negative sign. Now is integrate sign, you get the negative sign over there. Negative sign, S-I-N-G. S-I-G-N, sorry, not S-I-N-G. Okay? Yeah. Can? So be careful of this.
Just memorize this.
Yeah, memorize. Correct.
Okay.
Memorize it. If you are going to memorize, right, I would say memorize this one.
Okay.
Why? Because I find that over time, when those who try to memorize both sets of formulas, they get confused. They sort of like, when you differentiate and integrate, they mix up some of the results. So I don't want you to get mixed up. So focus on one. Make sure you put a lot of stars here, then when you transit over, it's easier for you to transit lah, that type of thing. Yeah. But I feel these three you need to know. These three of them. You should know very well. Okay? Yeah, this one is more secondary 4. Very common. Here is set 4 plus JC. Yeah, if you go JC, all these will be all common. But set 4, some question will still ask on the second column. Yeah, so just be careful. Even Cambridge also, they'll ask. Yeah, so just be careful a bit. Okay. Next,
Wait, can you
yes.
re-explain the why when you integrate the differentiated sign, you still get sign?
This one Oh, actually okay, I erase it and see Yeah, actually all boils down to this thing. Yeah, people talk about dy dx, for example then dy dx. Then people talk about, is there a reverse operation? Like you do something right, you go out of your home, now you want to come back to your home, that type of thing. So is there always a two-way traffic? So like I have a y, I can differentiate, I get dy dx. Then when I want to go back, then what to do? What should I need to do? So for example, if I have a x term, I square it, I become x squared. Then if I square root, sort of like I get back x. I put in this open inverted commas y because got plus or minus lah actually. Okay, yeah. So from x to x squared, and then I square root it. The square root is like a reverse process. So I unwrap the square term, I get back x itself. So something like that. You go Christmas party, you keep unwrapping your present inside then yeah, that type of thing. You wrap back, you wrap the present, someone unwrap the present. Yeah, so here I want to go back. So to go back, people talk about the reverse. Like that. So if I reverse, then I get back to the y. Therefore, can you see? Can something like that there's not a very good explanation to that. It's just a very natural human question. Whatever you do, can you reverse the process? That's all. Yeah, even people talking about burning of papers, they say burning papers, burn already become soot, become ashes. Then can we reverse the process? Can be done. It's just very difficult. Maybe can be done. Okay, not at our technology. Okay, yeah, everything should have a reverse process yeah, it's just whether we can discover it. Okay, so yes, can. Yeah, so we move on a bit move on to the next result. I'm compressing the results so you'll find that wow, all these things like you're taking it a lot, right, at one go. Yeah, it's true okay. So the next result is this theorem 4. Now what's the difference? Not much difference the only difference is instead of the x angle, now the angle becomes ax plus b. Okay, ax plus b. So I just show you one example. For example, integrate cosine, you get sine. Again, I don't want you to remember all these formulas. Okay, I just want you to remember such that you remember something to trigger you to remember something else. You get the idea? Yeah, something like that. So like when Phoebe sees Angelina, then she'll remember, oh, there's a test in 1 month's time. Then something like that So whenever Phoebe sees her face, then she will, oh, yeah, there's a test coming, that type of thing. But she doesn't remember the test, but she remembers Angelina that will trigger the remembering of the test. Something like that. Okay? Yeah, so you see if I know how to integrate cosine, I get sine, then I integrate this one, this term, this s then I will get sign again. Do you see how people remember things? I remember in this way. I get sign again. Maybe I write below, easier to see. I get the sign again. Except that I need to be careful. Having the prior experience of a linear function, there's a chain rule effect. So the chain rule is I need to divide by a. Do you get this? So it's a combination of just now the knowledge of a chain rule, you reciprocate it, plus the current trigo knowledge of integration. Yeah, usually I remember things like that. I don't remember the whole formula. I remember that cosine gives me sine. Then after that, if the angle is as plus b, I need to remember, oh, that is something different. So I need to get aware of or beware of the term, be more careful of the term. As plus b. Then I differentiate as plus b, I get a, I 1 over a. Is that matter okay? Can So if let's say I integrate this one, then I remember differentiate tangent is secant square. So I integrate secant square, I get tangent back again. It's a reverse process. So if I remember this, then I won't be afraid of this term. If I find that, oh, this term is simple, I will definitely get back tangent. But then I need to be careful. This is not the ordinary angle. This angle is as plus b. So I need to differentiate it. Then I differentiate, I get a. So I 1 over a. Yeah, okay. Actually, like this very simple formula, right? We also have the differentiation process. For example, here, this is x is 1x. I differentiate x is 1. So I over 1 over 1. You get me? Yeah, so the reverse chain rule is always present in every integration process. It's just that we learn simple formula, they don't come out that clearly. Yeah, okay. So I would say this theorem 4, no need to remember. You just need to know the angle gets complicated, you need to take care of the angle with the chain rule. Yeah, so basically I would say that the differentiation rule is very important. Then use the differentiation to help you to remember the integration. But these three, if you can remember, would be good because you can respond faster to problems. Okay, so let's look at the problems. We look at example 10. Very interesting question. Trigo is the hardest integration problems. Yeah. Then once you can do integration for Trigo, you can do other types of questions without much problem. Okay, example 10a. Integrate the following with respect to t. Yeah, okay, I write down the question. I bring you back to the formula list so that you can refer to the formula, okay? So here, this is the question. These are the formulas. Okay, then pay attention to the 3-star column here. Yeah. Okay, so here if you refer to the table, right? Okay, then you'll get directly sine is negative cosine. So the 2 is left behind. You always leave the number aside, then it's negative cosine. Can follow? This one, first one. Then second one, plus leave the 3 behind. Then cosine is the first one. So we integrate cosine is sine. Then plus c after that. Yeah, we are trying to move ahead if your school hasn't taught this part yet. So that when you go back to school, even if they rush it, there might be a rush. You get what I mean? Because now a bit of disruption here and there. Then when you go back to school, if you're going to have your O level still in place, they're going to rush. If some schools are slower, they're going to rush and then keep to the deadline. Then everything will be bottleneck at the end. Yeah. So if you learn all these things, then maybe you have more time for your mind, your brain to accept. Then when you rush by the school, also okay. Okay. Yeah. You'll find now it's only April. Then I only have one more major topic to finish. Then what's the big deal? The thing is that we need to revise okay, so there'll be time catered to revision. So revision part will be important for those taking O level. You have to revise from set 1 to set 4. Yeah, of course, most of the time set 3 set 4 should be enough for you to handle things. For IT also you won't only test on set 4 you will be tested mostly on set 3 set 4 stuff. Yeah, these 2 years. Okay, this is final answer for A. Okay. Yeah, answer is below here. So we got part A done. Part B. We look at part B. You get exposed to different questioning. Be sensitive to the terms given to you. So this is your problem. Then we refer to the list. Yeah, we find that for this case is here cosecant cotangent. Okay, but a little bit different. The angles a bit different. Yeah, so you be careful of the angle thing. So now we do the integration. So the 1 is t. 1 is the number is a t. So you get a t. Don't forget your algebra. Then minus. We are looking at this guy. Yeah. So we get back negative cosecant. So put a negative here. Just get the trigo term sorted out first. Okay. Then after that, again, as I said already, look at the angles. The angle is not the simple x, so it's a 2t. Both are 2t. So you need to do a chain rule. So the chain rule is 2. This gives us half. Yeah, so the differentiation chain rule will come in pretty useful. Okay, so yeah, remember this, especially if you go JC, they will keep testing you on this chain rule, the reverse chain rule, very very rampant in JC. Yeah, so after that, just simplify it a bit. Yeah, so this is your part B. So you get this term, this term. This is a cosecant. It's a shorthand for cosecant. Okay. You know our modern trigo symbols, they are changing. We used to think that this is short, but they want it shorter. So that every sine, cosine, tangent, all will be in 3-letter words. They all keep it synchronized into 3-letter words. This is the more modern symbol. So you all are older already. Okay, the children next time they will be learning this. Yeah. Okay. Part C. Part C, I erase this part A and B. For trigo, there's always that difficulty of the problem. Okay, so integrate this guy. This for C. Then we go back to the formula. Yeah, you'll find that the first term is a bit troublesome because it doesn't appear directly to us in the formula list. Okay, it doesn't appear there. Yeah, so but sine square 1 over sine square is cosecant square. So you have to, get a bit flexible, make it to cosecant square. right? Yeah, so 1 over sine square is cosecant square. Then you need to be familiar. Then you get cosecant square. Then the cosine 3t, leave it. Because cosine 3t is prime for us. Okay, it's just good for us to yeah, to do integration. Okay, now we can do already. The first term is from here, second term is from the first formula. So cosecant square integrate is negative cotangent. Then we have negative cotangent. Settle the trigo first. Then before you go to the next term, you take a look at the angle is not the simple angle. So you need to do a chain rule. Differentiate 40 is 4. So you reverse reciprocate. Then do the same for cosine. Cosine different integrate is sine. So you get the trigo term sorted out first. Then again, the angle is not simple. So we differentiate the angle is 3. So it's 1/3. Then you get plus C. Get it? Can yeah. So where's the plus C? Then we simplify a bit. So we get plus C. Then we get negative 1/4 cotangent 40 minus 1/3 sine 3t plus C. So check the answer. Yeah, so this answer we got it. Next one. Okay, next one. Ready? Finish copying. So far so good. Good, yeah. So we look at D. Is sine t plus cosine t multiplied with the sum multiplied to sine t. Yeah. Then okay, what to do with this question like this? This question is the beginning of the maybe I would say level 2 question. Level 2, whereby you need to have some workout with the brain. Yeah. So here we'll maybe multiply out, because you cannot just integrate it directly because there's no formula for us to do it directly. Okay, so we will multiply out. After you multiply out, the situation doesn't get that much better. Okay, but at least, right, instead of looking at the problem as one, you now divide the problem into 2 little smaller problems. Okay. Then what to do? For trigo, right, you cannot get away from trigo identities. Okay, so here we are going to look at using of trigo identities. And you guys familiar with all these terms using trigo identities? Like for example, this one. You should get familiar because this is your sine 2a formula. Right, it's from sine 2a. So we will use this formula for this term. And the other one, we will use double angle for cosine. Especially in particularly this formula. Why? Because in our integration formula, right, you'll find that the formula with the square terms only come from cosecant square and secant square. There are no formulas for sine square. So if there's no formula for sine square, then we need to switch it to other forms. That's where the trigo formulas come in, the identities, where they allow you to switch the trigo form into a form that you can perform integration. Yeah. So here you'll find that why not I just remember all the single trigo formula. I tell you, you'll die very soon. Okay, because there are so many different formulas, how to remember. So you just need to apply. Okay, so we do it this way. We continue. We apply the formula for sine square. We make sine square the subject. Okay, and then we express it as this way. You see, can follow or not? Maybe I put it down a bit lower. Okay, then you can see the bridge already, the connection between them. Get me? So I get sine square. That's a square term. So I get sine square a or sine square t to be 1 minus cosine 2t over 2. Get it? Then for the next one, I will get, using the sine 2a formula, I get sine 2a over 2. So I get sine 2t over 2. Yeah, so this will be the formula applied to the terms. Yeah, you can see that this will be a level 2 question. Probably will be quite in the exam they'll be mixing level 1 and level 2. So they will begin with a level 1, then after that they will just throw in some level 2. You will definitely see level 2 question. Definitely. It's just how much, what's the amount, that's all. Okay. Then after that, we just separate it into the two fractions. Yeah, just separate them. Then we integrate term by term using the formula as shown. Okay, as shown. So use the formula. Half will be just half t. Then the second one, cosine is coming from here. Integrate cosine, you get sine. Leave the half alone, you get sine. Then don't forget the angle is not the simple angle, so you need to do the chain rule. You get 2 and you reciprocate it. Then the third one, plus half. Integrate sine is negative cosine, so you get negative cosine 2t, and the angle again not the simple angle, is a 2t not t, so you chain rule it, it becomes 2, in integration becomes half, and plus c. Yeah, I'm trying to keep reminding you all the how to remember formula lah. So get the trigo in, then find out whether you need the chain rule or not. Yeah, so if you go through this process in this way, it'll be good for you in the future. Okay. Yeah, so the answer will be like this. We check answer. T over 2, half, 1/4 sine. Yeah, so this is our D. Yeah, then we finish. Okay. Yeah, maybe you can finish, huh? Yeah. So E. Okay. E is this I copy down the question. E is considered interesting question. A lot of things to worry. Yeah, so this is the question. In the formula list, there's no such a form at all for us to integrate. Yeah, so we cannot use the formulas, any of them we also cannot use to directly do it. Yeah, so we need to do something to the trigo. What to do? What to consider? When you see a question like this for trigo, right? Normally, just like solving trigo equation, angle becomes a very important part of your process. Okay, so think of what to do with the angles. Okay, think of what to do with the angles. They are very important. A lot of the great things will start from the angle. So to perform integration or solve equation of trigo, right? Then if the angles are the same, you'll have a higher chance to solve, to progress. So you're going to make the angle the same. Okay, making same angles will increase the chance. Not necessarily can solve for you, but increase the chance. You have a better chance to solve. Unless the question is a tricky type of question, very evil type, then you cannot. You have to do it in a very special way. If not, then normally getting into the same angle will be good, and we are going to focus on getting the cosine 2t to be t. Okay, so we are going to use this formula. There are a few formulas, right? This one, this one, the one that you just see, this one, right? You just seen the 1 minus 2 sine square a. Yeah, so in this formula of cosine 2a, which formula should we use? Yeah, cosine is the one always the tricky one, because cosine has options. Options not always good. Yeah, next time you go uni, wow, it's good to have options. Then you can go the best uni, the lousiest uni. You want to go to the US, you want to go to UK, good. But sometimes too many options, people don't know which one to choose, and then very frustrated. No? Yeah. So here, three formulas. Which one to use? We'll use the second one. The reason is, right, the second one will kill the plus one away. Okay, normally it's good, no? When your denominator is fewer terms, the fewer the better. Okay, if you can kill something, just kill not kill human, kill the terms. Okay, so you just kill off that plus one by using the formula. Okay, so the plus one. Normally, we will choose the formula most of the time in this sort of situation to get rid of some terms. Yeah. Okay, so the plus one becomes very important. If one day you see it's a minus one, your decision will change. You'll change to this formula if it's a minus one, because the one and minus one will kill off each other. That kind of thing. So your decision will base a lot on the surrounding of the terms. Yeah. Okay. So can, if can, we proceed on. I proceed on over here. So your integration becomes cosine 4 power 4t plus 2 over 2 cosine square t. Yeah, take off we remove the 1. Then what to do next? When your denominator has 1 term, only usually good to do split. Okay, not your barely splitting, it's the split the fraction term. Yeah, so you split the fraction term into 2 when there's only 1 term. I thought this is a important part of algebra. A lot of the questions they construct in certain special way, and it's not random. Exam questions you see, questions you see in the worksheet, they are not random. They are designed in certain way. Okay, and the blueprint to designing all these things, there are certain things to follow, and one is the 1 term denominator type of problem, where people will start to like split it into 2. In this case, yeah, splitting into 2 this way will sort of like make it easier to cancel terms away and so on. Yeah, so we get to this step, and well, we always revisit the formula. So the formula in the theorem tree, I will keep referring to this theorem tree, the result tree, as a basic direction of the formulas, because I want you all to remember fewer things. The fewer the better, then you can make it very strong, okay, to remember certain things. Yeah. Okay, coming to this part. Now you have your cosine square and 1 over cosine square. What decision to make? Yeah, you find cosine square again is not featured in any of the formulas. Only the square are the secant square and the cosecant square. So cosine square is no good. But this one is good because this is your secant square, right? Your second term is your secant square, which is good. It's here. So I just make a remark. So this one is good because of this part. 1 over cosine square is secant square. So you need to transit very quickly. Secant square, cosecant square, all these things. 1 over sine square, 1 over cosine square. Must transit quickly. Okay? Then you can cut down the thinking time. Now we focus on this part. And if you notice, just now we did an earlier problem, right? We're going to use a trigo formula. So cosine square, we're going to use this one, the one in the green color. Okay? So we are going to use the formula for trigo double angle. Then we get half. Make cosine square the subject. Okay, so we have cosine 2t plus 1 over 2. This is for the first term. Then second term is we deliberately write as secant square. Okay, then after this, then we good to go. We just simplify the fraction. Split them into again, it's a single denominator term. Remember, single denominator usually we love to split. Yeah, so split it and get every term ready before you integrate. So one shot integrate everything. So keep the 1/4. Then cosine, integrate is sine. Okay, then be careful of the angle. The angle is not the usual one. It's a 2t. So we multiply a half. Then 1/4 is 1/4 t. Then lastly, secant square, we use the formula directly. No tricks. This one, use this formula. Yeah, so we get tangent t. Then plus c. Simplify a little bit, we get the answer. Yeah, so this will be the parts we have. Okay, so trigo integration is a bit more colorful, right? You need to take care of using of trigo formulas. Yeah, so yeah, very important. Okay, okay, we take a little short break, a stretch break, then we come back. Lesson break. Yeah, then we do the app. Yeah, go away from the screen. 1 day 4 hours only. Okay. Okay, I mute. Okay, mute. Yeah. Any questions so far? Can follow the lesson? Can? Okay. Yeah. Endure a bit. After October, then you have a few months to rot. Yeah. So just look forward to it. Okay. After October. Yeah, because your major exam will end in end of October around there. Okay. And in end of October, then your next, if you study further, if you have further study that type of thing, then you will start your education in February. Those going poly even better. Wow, I tell you, I've taught a student, then she graduated, then she was waiting for poly, then she did nothing. Yeah, nothing. Then like rotting at home, then don't know what to do. At first was very happy, After that, after first month, everything you did whatever you want to do. Then after that, slowly you find nothing to do. Then it's like, someone, I don't know lah, have to go and see doctor that time. Yeah, I don't know what to do until July, then start schooling. Yeah, so whatever you do here, work hard. Then after that, until end of October, finish. That's it. Yeah. Okay. Then work hard. So we do F. Okay. Yeah, F. Integrate tangent square. Yeah, integrate tangent square. Just one term, but if you take a look at the formula list, there's no such a tangent square thing. So again, tangent, the square only for secant square and cosecant square. So again, as anticipate the use of formula lah. Yeah, so in this case, we are going to use a formula. What formula to use? Tangent square. You recall something? This one. Yeah, that means when you recall the formulas, right, the formulas preferably should be connected to the formula list. All these formula like secant square, sine, cosine, secant, cosecant, cosecant square. Okay, you try to relate so that the formula will give you a way to connect to the formula list. Okay, then after this, with this formula in mind, we will express tangent square as secant square minus 1. So we write in this way, but with the angle. Yeah, copying back the angle, don't copy A, you'll get it wrong. Yeah, then after that, yes, we can do already. We use this formula. Secant square is tangent. So we integrate. Then we get tangent. Okay, get the basic formula for trigo, right? Then after that, do the chain rule, reverse it. So 2t plus 1 is 2. Then reverse it, it will be half. Then minus 1 is t plus c. Can So with this, we simplify a bit. Then that's it. Finish for this question. So it's not that bad. Then we don't do G and H. They are there because of accident. So don't do them. Okay. We'll move on. Yeah. I'm not interchange you lah. It's just that they belong to another type of formula that we don't learn yet. Yeah. Okay. These are the homework. No. Homework. Yeah. 2 questions. Okay. Yeah, homework, 4071C. Later on, I will WhatsApp. I also have to copy down. 1 and 2, 3 is cannot be done now. Okay, 3 is 3 will be like just now the 2 other Trigo questions. They are not at your level yet. Yeah, so we don't do first. You have to learn something else, then you can do. Okay, next we move on. We rush through this. Okay, section 7. You know, this lesson we are covering all these different techniques. Okay, so this one is the last part already. Exponential and reciprocal linear function. So I just tell you how to remember. So this one becomes a bit too much. Okay, I tell you what to do. When you differentiate e to the power ax plus b, what do you get? Okay, Phoebe, what you get? Don't ask Phoebe. She's eating. Sarah?
It is you copy the same thing but then times A.
Correct. You copy the same thing. Well said. Very important. Remember what she said. Copy the same thing, then times A. So this is your simple exponential differentiation. Then how about integration? Integration is about the same. You copy the same thing, but instead of times A, you divide by A. Then plus the C. So simple. So it's here. Copy the same thing. Instead of times, you divide. Then you plus C. Then that's it. Yeah, so this one. Then how about the other formula? Okay, you learn this formula, right, in integration. The basic one. Then we learn that if you integrate x to the power n, you get xn plus 1 over n plus 1 plus c. Then people question something. People ask, a very simple question. Then this question actually made mankind sort of like going through 100 years plus to find an answer. Yeah, if n is -1, this formula is out, right? Because you cannot divide by -1. 0. Cannot divide by 0. So this formula becomes not useful for the case of n equal to -1. So what is n -1? N -1 is your reciprocal function. Okay, so this guy, right, with the power -1 becomes a very special guy, whereby mathematicians tried to use some other ways to find the answer for the integral, and they finally found it after 100 years plus. Okay, then they found that this is equal to ln x plus c. You remember differentiation of ln? You differentiate ln, remember? Differentiate ln x, you get 1 over x. Remember this? Yeah. Then you find that if I reverse the process, right, I get, remember all this unwrapping the present thing? Yeah. You differentiate, you integrate is to unwrap back everything. So you get ln x. Can? So something like this. Can? But how come there's a modulus? You find that differentiation no modulus because the question is differentiate ln x. When you differentiate ln x, right, when the question posed to you, differentiate ln x, give you, then you assume in your mind x must be positive. If not, if it's negative, then I can't even differentiate because it's undefined. You get me? You cannot ln a negative number. So for ln x, you differentiate, you get 1 over x is assuming x is more than 0. Okay? But if you reverse the process, people ask you, I integrate 1 over x. What do I get? Then I say that, well, what is x? Can x be negative or positive? So they find that they need to put a modulus to make it meaningful. You get me? Because here it's not protected. Your x can be positive or negative. No one knows. But over here, the x suddenly is going through a ln. So you need to protect it. in a way. I'm explaining in some common sense layman way lah. Okay? Yeah. Can? So for integration of 1 over x, right, you must have a modulus for the ln. Must, if not, your thing will be wrong. The result will be wrong. Okay, so let's go further. Okay, now you understand or you get it, something like that. You integrate 1 over x, you get ln x plus c. Okay, then we extend it to this question. You see, you understand this? Is that we'll do the normal ln, normal stuff, but we have to differentiate and reverse it. Okay, you get this? So this little chain rule effect will always be present in any algebra, trigo, ln, exponential. It's present in any mathematics. Okay, so do you see the basic formula is you differentiate, you integrate 1 over x, you get ln. You integrate 1 over something, you get ln. But you must be careful what is the something. If the something differentiate is a, you must 1 over a. Okay, what if the question is like this? Then you find that if I don't write, this is a wrong example. Okay, if I differentiate x squared plus 4, what is the answer? 2x, right? Okay, 2x. Then I do a 1 over 2x plus c. This is wrong. Okay, I need to warn you this. It's not like, in the future, anything also differentiate and 1 over. No, only number can be 1 over. Okay, so I tell you this. Reverse chain rule. I call it the reverse chain rule. Only applicable if the derivative is a constant. Okay, not everything in the under the world, under the tree or whatever thing, it can be reversed. Okay, so you only can reverse a number. You cannot reverse even a simple like 2x term. Can? Yeah, can. Yeah. So what is the result of 1 over x squared plus 4? This is a totally different ball game. Okay, so it's another different formula using very different formula to an idea to solve it. Okay, integration is a very, people say integration is like a person who is very petty. You very sensitive. You change a bit, cannot take it already. Then the person will be very angry. You cannot resolve the problem. Okay, yeah. So going back, you look at this one. We are done with the two formulas. So again, recall, integrate exponential, you will keep the exponential and 1 over a. Then integrate reciprocal, you will get a ln with a modulus, and then you 1 over a. Yeah, something like that. Yeah, so we look at example 11 very quickly. Yeah. First one, 11a. Integrate e 2x minus 1 dx. So very simple. We just copy back the term, differentiate 2x minus 1, and then over it. Yeah, almost like just copying the same thing. 11b. Integrate square root e 4x plus 3. Yeah, then this will become, you must sort out the power. Sort out the power first. So it's 4x plus 3 power half times half. Remember your integers. So here we get integrate e 2x plus 3 over 2 dx. Then integrate, we just copy back the term. Differentiate the power is 2, so you halve it. Not so difficult, huh? So we're done with these two. Part C. Integrate this term, what to do? Expand. We can't really do it directly, so we expand. Okay, we expand the term, you get integrate a squared minus 2ab plus b squared. So I will have a squared minus 2a b plus b squared. Then take care of your indices. You'll find that if you cannot do this sort of problem like expanding and so on, then it is your problem. It's your earlier problems. Yeah, so it's your those indices problem. Yeah, so here you just multiply powers. If it's power to power, you just multiply. And here 4, 2 times 2, 4, e to the power x plus 2. Here is a term times term, so the powers add together, right? Remember law of integers, you add the powers if they multiply. Then the last one is 4e is the power to power is times, so 3x times 2. Yeah, make sure all these powers laws you sort it out. Then after that, just integrate, copy the term, differentiate. Is -2, you reciprocate it. Then copy the 4, copy the e term, differentiate x plus 2 is 1, so no effect, no need to do anything. Then move on to the last one, 4. Then you copy the 6x term, then 1 over 6 because of the differentiation. Right? Then after that, we just simplify. Yeah, so this is our question. Yeah, then we finish off the last part, then we just make a clean stop to that example 11. Okay, remember your homework, your homework is on your just now the C, question 1 and 2. So lastly, D, integrate 1 over this thing. Yeah, this one is actually is nothing, just like the normal stuff, you bring it up, you change the signs of the power, then you just integrate, copy back the term, then 1 over the derivative. Okay, then you get the answer 2e -5 plus half x. Okay, that's all. Yeah. And so the next time we come, we will touch on example 12. Okay, then of example 12, then after that some other stuff. Then we are done. After example 12 is quite tedious, because you have to do, you remember partial fractions?